Light is both a wave and a particle. This is not approximately true. It is not sometimes one and sometimes the other. It is fundamentally, irreducibly both. And the opposite is also true. Light is neither a wave nor a particle, because these categories come from us, not from nature. Both statements are correct. Hold them together. Let the discomfort teach you something. I spent my life at the boundary where reality refuses to cooperate with our questions. Not because we lack better instruments or sharper mathematics, but because certain questions that sound perfectly reasonable, are not actually questions nature can answer. There is a limit built into the fabric of existence itself, not a limit on speed, as Einstein so beautifully showed, not a limit on energy or distance, but something far more unsettling, a limit on what can be meaningfully known. Let me take you to Copenhagen, to those long evenings at the Institute where we wrestled with what our equations were telling us. The mathematics worked beautifully, predicted experimental results with stunning precision. But what did it mean? What was an electron doing between measurements? Where was it? What path did it take? I learned to recognize these questions as the sound of classical thinking breaking against quantum reality. The photon travels through both slits, interferes with itself, creates a wave pattern on the screen behind. You see the interference fringes with your own eyes, unmistakable evidence of wave behavior, of the photon somehow sampling both paths simultaneously. And yet, place a detector at one slit to see which path the photon actually takes, and the interference vanishes. Instantly, completely. Now you have a particle, a localized click in your detector, a definite path. Not a wave spread across space, but a point traveling through one slit or the other. What changed? You did. Your measurement. Your interaction with the system. This is not a disturbance in the ordinary sense, not like checking tire pressure and letting out a bit of air. The photon does not have a definite path that your clumsy apparatus disturbs. It has no path at all until you measure it. The wave pattern is not approximately what happens. The particle detection is not approximately what happens. Both are exactly what happens, depending on the experimental arrangement, on what question you choose to ask nature. But you cannot ask both questions at once. Nature will not permit it. Heisenberg worked out the mathematics in those early days. Position and momentum linked by his uncertainty principle, not as a temporary limitation of measurement technology, but as a fundamental feature of reality. The more precisely you know where something is, the less precisely you can know how fast it's moving. Not because your instruments interfere, because the thing itself does not possess both properties simultaneously with arbitrary precision. The universe has placed a limit on the specificity of its own description. I remember the discomfort this caused, how Einstein, my dear friend, my hero, could never accept it. God does not play dice with the universe, he would say. And I would respond gently, Einstein, stop telling God what to do. We debated for years, with great warmth and great frustration on both sides. He believed quantum mechanics was incomplete, that beneath the probabilities lay a definite reality we simply hadn't accessed yet. Hidden variables determining outcomes, preserving the classical picture of reality existing fully formed whether we look or not. But the experiments kept speaking, and they kept saying no. Consider what you mean when you say, reality exists independently of observation. It sounds obvious. The moon is there whether you look or not. And yet, what does there mean for something you're not observing? What does it mean for an electron to have a position before you measure it? You might say it must be somewhere, it's simply that we don't know where. But this assumes position is a property the electron carries, waiting to be discovered. What if it isn't? What if position is something that emerges in the interaction between electron and measuring device? This was the heart of complementarity. Not sometimes a wave, sometimes a particle, but wave and particle as two complementary descriptions, mutually exclusive, both necessary, both correct, within their appropriate contexts. You set up a wave experiment, nature gives you waves. You set up a particle experiment, nature gives you particles. The electron is not hiding what it really is. It has no really is apart from the experimental context. The limit is conceptual. You cannot construct a complete picture from a single perspective because nature provides multiple perspectives that cannot be unified into one. Perhaps this sounds like giving up, like admitting defeat in the face of confusion. But I found something else in it, a deeper honesty about our relationship with the world. We are not outside reality looking in. We are part of it. Every measurement, every observation, is a physical interaction between the measuring device and the measured system. You cannot separate the observer from the observed because the act of observation creates the boundary between them. We are both spectators and actors in the great drama of existence. Walking through the streets of Copenhagen in twilight, I would think about language, about how our words carry the weight of classical assumptions, object, property, existence, location. These words evolved to describe tables and stones, not electrons. When we try to apply them to the quantum realm, they slip through our conceptual nets. Not because we're imprecise, but because quantum reality is not a smaller version of the classical world. It is something categorically different. And here is the truly unsettling part. This difference may not be bridgeable. Some of my colleagues held out hope that quantum mechanics was incomplete, that someday, somehow, we would discover the deeper level where electrons really do have positions and momenta simultaneously, where wave functions represent our ignorance rather than the actual state of affairs. But every hidden variable theory that tried to restore classical reality had to add something. Non-locality, faster-than-light influences, conspiratorial correlations. The price of determinism kept rising. Nature, it seemed, preferred the irreducible randomness of quantum measurement to the Baroque machinery required to fake it. I came to accept that certain questions do not have answers because they assume a kind of existence that nature does not provide. Where is the electron before you measure it? What path did the photon take? These questions sound reasonable. They have the grammatical structure of meaningful inquiries, but they're like asking what the taste of blue sounds like. Category errors disguised as questions. The measurement problem runs deeper than most realize. It's not just that measurement disturbs the system. It's that measurement is where the classical world of definite outcomes emerges from the quantum world of superposed possibilities. Before measurement, the electron exists in a superposition, not in one place or another, but in a state that contains multiple possibilities simultaneously. The wave function spreads through space. Then you measure, and the wave function collapses. The electron is found in one location. The other possibilities vanish. But what is collapse? When does it happen? Why does observation create definiteness from ambiguity? I do not know. I am comfortable not knowing. The theory works. It predicts. It matches every experiment we perform. Perhaps the question, what really happens during measurement, is another question that assumes too much, that tries to stand outside the system and view it from a God's eye perspective we do not and cannot have. Einstein thought this was giving up too easily. He wanted physics to describe reality as it exists in itself, independent of us. I thought, think. This desire imports a classical prejudice into a realm where it doesn't apply. Physics describes what we can say about nature, given that we must interact with it to know it. The limit is not a bug. It is the most important feature. On my coat of arms, I placed the yin-yang symbol with the motto, Contraria sunt complementa. Opposites are complementary. I had found in Eastern philosophy a comfort with paradox that Western thought resisted. Wave and particle, position and momentum, complementary aspects of a reality that refuses reduction to either. In those late Institute discussions, we would explore what complementarity meant beyond physics. Language and meaning, freedom and determinism, love and reason. Perhaps reality at every scale presents us with complementary descriptions that cannot be forced into a single framework. Perhaps the limit on knowledge is not just quantum, but universal. Reality is richer than any single perspective can capture. Or perhaps I am extending physics too far into metaphysics. This is the uncertainty I live with. But here is what I am certain of. There are questions you cannot answer, not because you lack information, but because the questions themselves presume a kind of reality that does not exist. The electron does not have a position and momentum that you simply don't know. It does not have them. These properties come into being through measurement, through the interaction of quantum system and classical apparatus. This is scary if you want reality to be independent of you. If you want to believe in a world that exists fully formed with all its properties definite and waiting to be discovered, that world, the world of classical physics, of naive realism, is not the world we inhabit. The quantum world is stranger. It is participatory. Your observations are not passive receipts of pre-existing information, but active participations in the creation of definite outcomes from indefinite possibilities. You are entangled with what you observe. Always. The boundary between subject and object dissolves under careful examination. Does this mean reality is subjective? That thinking makes it so? No, the quantum state evolves according to precise mathematical laws. The probabilities are objective. But which outcome occurs in any given measurement that contains irreducible randomness? Not randomness from hidden complexity, but fundamental bottom-level randomness. And the transition from potentiality to actuality happens in the encounter between observer and observed. We live in a universe that refuses to be fully known. Some find this depressing. I find it liberating. It means nature retains mystery not as a temporary gap in our knowledge, but as a permanent feature of what knowledge is. There will never be a final theory that answers every question, because there are questions that look like questions but aren't. The limit is built in. It is structural. It is beautiful. Perhaps the scary part is not the limit itself, but what it implies about our place in existence. We are not outside observers cataloging a finished reality. We are inside, participating, our observations creating the very definiteness we then mistake for something that was always there. The moon is there when you don't look, probably. At least it's an excellent working assumption for moon-sized objects. But the electron? The photon? They exist in a state that the word there does not capture until you interact with them. And here we reach the deepest layer. If the properties of things do not exist until measurement, if observation participates in creating what is observed, what does this mean for consciousness? For the observer itself? I do not know. The theory is silent on consciousness. Some have tried to make consciousness the key that collapses the wave function, but I distrust this. It smells of anthropocentric thinking, of making humans once again the center of the cosmos. Perhaps consciousness is simply how observation feels from the inside. Perhaps it is something the theory cannot address, because any theory of consciousness would require consciousness to observe itself, to measure the measurer. Perhaps the limit on knowledge extends even there. You cannot fully know the knower, because knowing would change it. Or perhaps I am old and tired and seeing complementarity everywhere, even where it does not apply. But the core remains. Reality places a limit on what can be known, not a practical limit, not a technological limit, a limit imposed by reality's structure itself. Certain questions have no answers because they presuppose a kind of existence that nature does not provide. And this limit is not something to overcome or work around. It is something to understand, to accept, to build into our picture of what knowledge means. The opposite of a profound truth is also a profound truth. We can know reality. We cannot know reality. Both are correct. The measurement reveals what is there. The measurement creates what is there. Both are correct. Physics describes the world. Physics describes what we can say about the world, given how we must interact with it. Both are correct. Can you hold these together? Can you sit with the discomfort of mutually exclusive truths, both being right? This is what quantum mechanics demands. Not as confusion, but as clarity about the kind of universe we actually inhabit. I do not know what lies beneath the quantum formalism. I do not know if there is a beneath. Perhaps the formalism is all there is, a mathematical structure that predicts observations without corresponding to any underlying reality we can visualize or describe in classical terms. Perhaps reality is stranger than we can think, because thinking itself evolved in the classical world and carries classical assumptions we cannot fully shed. The question remains hanging like a particle in superposition. What can be known? And I answer, less than you think, more than you fear. But never everything, never a complete God's-eye view that captures all aspects simultaneously from no perspective in particular. We are inside, we are limited, we are entangled with what we study. And this, I have come to believe, is not a tragedy. It is the condition of knowledge itself.